So this will just address a couple of questions about moments. The situation, this question is number 11 from the homework sheet on Forces 2, and we have the situation where a girl is standing on a uniform plank. It's 4 meters in length, and it's actually suspended at either end, A and B, by 2 vertical ropes. The girl, we're told, has a weight force of 300 newtons, and the plank itself has a weight of 500 newtons. Now, of course, we have to know that that 500 newton weight force of the plank will always actually be taken to exist at the center of mass of the plank. In this case, that's 2 meters from either end. And part A asks us to take moments about A, which is this end here. So I've marked in an imaginary pivot point in red, and this is the general technique that you need to get used to using for solving such questions. So you apply an imaginary pivot point at one end, typically one support end of any such plank or beam given in the situation. The second thing you always do is you write the principle anti-clockwise moments must equal clockwise moments to satisfy the first condition, or one of the conditions for equilibrium, which means the plank and the girl are in equilibrium, and this condition must be satisfied in that case. So if we consider each side separately, taking the anti-clockwise moments first of all, we have force B times the length that force B is away from the pivot point, the imaginary pivot point in this case, which of course is the entire length of the plank, 4 meters. There's force B there. Then the clockwise moments will be a combination of the girl's weight force times her perpendicular distance plus the beam itself, the plank itself, its weight force times its perpendicular distance from the pivot point. So we just have to add those together, and that comes to 1,360 Newton meters. We then divide the 4 across to solve for the unknown quantity, force B in this case. We get 340 newtons. That's after the 4 meters has been divided into the 1,360 Newton meters. Then the second question involves a couple of trestles. So this is the trestle labelled P in question 13. This is the trestle labelled Q. And we have a beam, which they give us the total length of 3 meters. That's from this very end here to that very end there. We're also told that the span, which is the distance between the two trestles P and Q, the distance between them is 2.5 meters. That leaves us a 0.25 meter overhang at each end. Now with that information we can calculate some other distances that will be useful for us. For starters, we know the actual weight is given to us as 50 newtons, and that always acts at the centre of mass of the object. And since it's a uniform plank, once again it's in the very centre, the geometric centre of the plank. In this case, it turns out to be 1.5 metres from either end, because the plank itself is 3 metres long. Taking into account the overhang 0.25 metres, we can calculate that the distance between this trestle and this weight force of 50 newtons is 1.25 metres. The other important distance to work out, if we can choose an imaginary pivot point, in this case I've chosen this trestle here, we need to know how far away the person is standing. For part A, they tell us that that person is standing 0.5 metres from trestle P, which is marked here in green. So using that information, we therefore know, and the other bits of information on this side, that that person must be 2 metres from trestle Q. The span is 2.5. If that person is 0.5 from this end, then there must be 2 more metres to the trestle Q. Taking now our principle, once again, we always induce this. Anti-clockwise moments must equal clockwise moments about any particular pivot point. We've chosen this one, this imaginary pivot point to be here. As mentioned, we always end up choosing one of the supports for these types of questions. So, anti-clockwise moments will be made up of 2 forces. The first one is the student whose mass is given as 60 kilograms, and we're told to use G, the acceleration due to gravity, as 10 newtons per kilogram. So 600 newtons is the weight force times 2 meters. That's the moment caused by the student standing at that particular position, plus the moment caused by the weight of the plank itself, which is of course 50 times 1.25 meters. That must equal the clockwise moments. In this case, it's given by the force of P, the trestle at the left-hand end, times the distance away from the pivot point, 2.5 meters. That's the span between the 2 trestles. So we solve both sides. That this sum ends up being 1,262.5, and this side, of course, we have to divide away the 2.5 to that side to get FP, 505 newtons. The next step, because we're asked to actually calculate the force exerted on each trestle, that's both P and Q, is to use this principle, the other principle for equilibrium. All the forces must sum to 0. In this case, the important forces are vertical, so all the upwards forces supplied by the trestles must equal all the downwards forces caused by the load, the weights in this case, and they all sum to 0. So considering the upwards forces, first of all, we have the 505 that we've just calculated for the trestle P plus trestle Q's force, we'll call that FQ. That must equal the sum of the downwards forces, which of course includes the 600 Newton student and the 50 Newton plank. So just a simple sum here, we subtract 650 from 505 and we get the answer for the force exerted on trestle Q as 145 newtons.